This is GATE 2016 set 2 electrical question number 19. A three-phase diode bridge rectifier is feeding a constant DC current of 100 ampere to a highly inductive load. If three-phase 415 volt 50 Hz AC source is supplying to this bridge rectifier, then the RMS value of the current in each diode in ampere is being asked. For NPTEL reference, you can refer lecture 3-phase rectifier capacitor filter of the NPTEL course Design and Simulation of Power Conversion using open source tools by Professor L. Umanand, Department of EECS, IISc, Bangalore. Coming to the useful data, for a three-phase signal RGB shown in the figure, when applied to a three-phase diode bridge rectifier like this, then diode 1, diode 2, diode 3, diode 4, diode 5 and diode 6 conduction periods are mentioned here in the table. The easy way to determine which diode will conduct at what periods, just see this. When this portion is maximum, when R portion is maximum compared to other two phases, then the duration for the R phase being maximum compared to the two phase is the duration for the upper leg of that particular phase diode to conduct. So the upper leg means this D1, D3, D5. Lower leg means D2, D6, D4. Now I told you that see which phase is maximum compared to the other two phase. For that duration, the diode of the particular phase will conduct. Now if it is in upper, that is positive, then upper leg will conduct, and if it is negative, that is that particular phase is negative maximum, then lower leg will conduct. So for example, see for R phase the dedicated diodes are D1 and D4. For G phase the dedicated diodes are D3 and D6. For B phase dedicated diodes are D5 and D2. Now for R phase, when R phase is maximum between 30 degree to 150 degree compared to the other phases, the upper leg, that is, since it is positive maximum, upper leg will conduct between 30 to 150. So 30 to 150 we see D1 is conducting. Similarly, a random case picking up, I am selecting a random case. Let's say when the B phase is negative maximum, then the dedicated diode D5, D2, since it is negative maximum, so D2 will conduct between 90 degree to 210 degree, because between 90 degree to 210 degree B phase is reaching negative maximum. So the lower leg of B, D2, will be conducting in this particular duration. So we see 90 degree to 210 degree D2 is conducting. Similarly, we determine the sequence of conduction of the diodes, and for the diode bridge rectifier arrangement, it is seen that every diode conducts for 120 degree. For highly inductive load, the load current is constant. So if you find the average over that conduction period, that is 1/3 cycle conduction period of every diode, then it will come out to be I0 by root 3. So ID RMS is I0 by root 3. Therefore ID RMS equal to I0 by root 3 equal to 100 by root 3, 57.7 ampere. So the answer is 57.7 ampere. Thank you.